All right. Okay, so numbers 1 and 2, we're just writing our equation in log form.
Okay.
Okay. What would you do there?
So that would be log 3 negative 2 equals 729.
Log base 3 of...
Oh, 6. Sorry. I was looking at the one right below it. Whoops. I took the
Okay.
negative 2 from that. Sorry.
So say it again. How would you convert that to?
So log base 3, 6 equals 700 and...
So the
No,
order is going to be a
no,
little
no.
different, right?
Right. That would be...
So it's going to go in the circular form there.
Right. So log base 3, 729
Yeah,
equals 6.
there we go.
Okay. And this would be log base 8, 4 equals 2/3.
Mhm.
Okay. Number 3, this would be 5 negative 2 equals 1/25.
Mm-hmm.
And x plus y to the third equals z.
That's right. Yeah. Base x plus y raised to the third power equals z. We kind of go in a circular way and pick up all numbers around that
Right.
circle.
Okay. This is where I set it equal to x, right?
That's right.
So 6x equals 1/2116.
Mm-hmm. So now we want to solve for x.
Right. So,
Maybe there's a common base that we can find.
oh, right. Could we do, for the 1/216, could we do 6 to the -3?
That's right.
Okay. And then the 2 6s would cancel out, and x equals -3.
Mm-hmm.
Okay.
There you go.
Okay, and then this one, the 729 can go 9 to the third, so that would equal, our x equals 3.
Right.
Okay.
Okay. Number 7.
Okay, so 0. Can we convert the 0.1 into fraction form?
Yeah. Mm-hmm.
Okay. Um,
So 0.1 is 1 over what?
1/10.
Yeah.
I don't know what I would do here.
Okay, so convert to exponential form.
Okay. So that would be 10x equals 1 over 10.
Mm-hmm.
So would I have to convert 1 over 10 to somehow be 10 to the power of something?
Mm-hmm.
Okay.
Maybe a negative exponent can do the trick.
Right. Oh, would it 10 to the negative 1?
Yeah.
Okay. So x equals negative 1.
Right.
Okay.
Okay, condensing into a single log.
So log 2x to the 4th minus log 2y to the 6th
Yeah, bring the
is
exponents up.
log, right. And then that'd be log 2x to the 4th over y to the 6th.
Yeah, quotient property.
Okay. This is going to be log x to the 2nd plus log x plus 2 equals log x to the 2nd times x plus 2.
Mm-hmm.
Expand. Okay. This is log 3, 12 plus log 3b to the 4th. And then log 3, 12 plus 4 log base 3b.
Yeah.
Okay. Okay. Log base 2 c to the 3rd minus log base 2d. 3 log base 2c minus log base 2d.
Good.
Okay. Okay. Could we take the log form of each side?
We could, but I think there's an easier path to the answer here.
Dividing 5 by each side?
What do you notice about the bases?
Oh, they can become the same number. What is that called?
Mm-hmm. We can set the bases equal to each other, right?
Yes.
Or create
Okay.
same bases. Yeah.
Right. This is 5 negative 2 equals 5x plus 2. 5's cancel out. Negative 2 equals x plus 2. X equals negative 4.
Right. Yeah, once the bases match, we can remove them and just focus our attention on solving the equation on the exponent side of things.
Right. And then the next one is 4. 5x minus 1 equals 4 to the 4th.
Yeah.
So then the 4's cancel out. 5x minus 1 equals 4. 5x equals 4 plus 1. 5x equals 5. X equals 1.
Yep.
Okay. Can we condense the logs first?
Yeah. Mm-hmm.
Log x plus 3 over x
Mm-hmm.
equals 1.
Mm-hmm.
Can we move the 1 to the other side, or
Well,
Mm,
we have log form, right? We're trying to solve for x, but the x is kind of stuck inside that set of parentheses.
oh, could we convert it to exponential?
Yeah, convert to exponential.
10 to 1 equals x plus 3 over x. 10 equals x plus 3 over x. Cross multiply. 10x equals x plus 3. 9x equals 3. X equals 1/3.
Yeah.
Okay. Okay. Log base 2, 2 to the third, plus log base 2x equals 6. Log base 2, 2 to the third, x equals 6. So 2 to the 6th equals 2 to the third x, which is 2 to the 6th equals 8x.
Mm-hmm.
Okay, and then 2 to the 6th is 64.
Mm-hmm.
So x equals 8.
Mm-hmm. Right.
Okay. Solve for x. I'm a little confused here.
Okay, so 16. Well, the nice thing is that they all have same base, but we can't quite get rid of the 5 until we have a 1-to-1 relationship. So is there anything that we can do to maybe merge these together? So we have this property here that says if I have a to the m times a to the n, if I multiply bases, I can do what with exponents?
Add.
Add, yeah.
So that'd be 25 5x minus 6.
Oh wait, but when you multiply the base stays the same.
Oh, okay.
It's just the exponents that gets added together.
So 5x minus 6.
Mm-hmm.
Equals 5x plus 6. 5's cancel out. 5x minus 6 equals x plus 6. X equals 3.
Yep.
Okay.
Oh, something I forgot to talk about with number 14 and 15. What should we have done when we solve for x?
Oh, check.
Yeah, check for extraneous solution.
Solutions.
So, but did not have any issues, right? Did not cause this
No.
parentheses to be negative or 0, and it's safe with this argument as well.
Right.
The 8, nothing to plug in here, but the 8 is good with that argument.
Yes. Okay. We're gonna have to take the log of each one, right?
Right. Ideally, we can just get the bases to match, but 5 and 10, we can't quite get that to happen. So yeah, we got to take the log of both sides.
Okay. Okay, so that's going to be log 5x minus 2 equals log 10, 2x plus 1. Okay.
All right, what can we do next?
So then you bring the exponents to the front of the log, and then that's x minus 2 log 5 equals 2x plus 1 log 10.
Mm-hmm.
And then you distribute the x minus 2 and the 2x plus 1.
Yeah. What's
And
nice
then,
about log? Okay, go ahead.
oh, sorry.
What's good about log 10?
Oh, it can cancel out.
Yeah, base 10 with a value of 10. Yep, so that makes it nice on that right side.
Oh. Okay. Oh, so that's just going to completely cancel out.
Right. The right side is just 2x plus 1. We don't have to worry about any log attached to it.
Got it. So then, okay. So then you bring the x's to the same side.
Good.
And you can take an x out, and then you get log 5 minus 2 equals 2 log 5 plus 1. So x equals 2 log 5 plus 1 over log 5 minus 2.
Yeah.
Okay. Okay. So this is 5e equals 3x plus 2.
Where do we start? What's the base?
Oh, right. So we can make the ln log e, right?
Yeah.
Log base e. 3x plus 2 equals 5. And then 5e equals 3x plus 2.
Let's start with the base, though. What's the base?
What do you mean?
The base is the e, right?
Right.
So it's e to the 5th equals 3x plus 2.
Oh, right. I was reversing that.
Okay.
E to the 5th equals 3x minus plus 2. So then it's e to the 5th minus 2 equals 3x. And then e to the 5th minus 2 over 3 equals x. Okay.
This we do need to check for extraneous solutions.
Okay.
But if we imagine ourselves inserting this into the parentheses, the 3's will cancel out. I'm left with 3e to the 5th, or actually the 3's cancel out. I'm just left with e to the 5th minus 2. The positive 2 and negative 2 cancels out. I'm just left with e to the 5th, so we're safe. No issues with negatives.
Okay. Okay. So first I'm going to condense this. So ln x over 3 equals 0.
Mhm.
So then log base e x over 3 equals 0. E to the 0 equals x over 3.
Mm-hmm.
And then e to the 0 is 1
Mm-hmm.
equals x over 3. So x equals 3.
Mm-hmm. Any issues with extraneous solution?
No, that works.
That works.
Okay. Use natural logarithms to solve the equation. Do I have to convert this to log form?
Yes. Yeah. So anytime I'm trying to solve for x and I can't get the bases to match, yeah, I'm taking log or natural log to bring that down. You can do logs as well, but yeah, natural log is just going to be nicer with base e.
Okay. So that's log base e to the x equals log base e 5/7.
Yeah.
The log base e with the e cancel out, so it's just x equals log base e 5/7, so x equals ln 5/7.
Good.
And I think that works.
Oh, we don't have to check because this is not a log equation.
Oh, okay.
So yeah, if we don't start off with log equation, we're safe. We can just whatever answer we get, we're
Got it. So this one I subtracted the 1 from each side, and then I got 3e to the negative x equals 6, and then I divided 3 by each side, and I got e to the negative x equals 2. So x equals -2. No. Because we have to, that would be negative x equals natural log of 2, right? If you were to make, yeah. And then you'd have to bring the next. So x equals negative ln 2.
Yeah.
Okay.
Good.
Yes.
All right. All right, on to graphing.
Okay. So this shifts left by 8.
Yeah.
Shifts down by 4. And our vertical asymptote is -8. Okay. So what's the property stuff again?
Right. So here are the properties. If I have log base b of 1, that's going to be equal to 0. If I have log base b of b, that's equal to 1. If I have log base b of 1/b, that's equal to -1.
Okay, thank you.
And then if you just know these three things, you can figure out the other side because you can ask yourself, b raised to what power is equal to 1? You know it's going to be 0.
Right.
B raised to what power equals b? You know it's 1. B raised to what power equals 1/b must be -1.
Okay.
Okay, so table of values.
Right. So
Is VA.
right. And if we do where we make inside the parentheses 1, that'd be -7. And
Yeah.
then since that log thing would equal 0, that'd be 0 minus 4, making it -4. And
Yes.
then
7 and 4. Yep. Log 1 is 0. 0 minus 4 is -4. Okay.
and then to make inside the parentheses equal 8, that would be our x
Well,
is 0.
Not 8, but
Oh, 2.
2.
Okay. That would be -6. Which then, since that's 1, -4 or -3 would be our y.
Yep. Log base 2 of 2 is 1, and 1 minus 4 is -3.
Okay. -6, -3, -7. Okay. Our domain is -8, infinity.
Mm-hmm.
Our range is -infinity, infinity. Our asymptote is x equals -8. And I'm going to find the x-intercept.
Set the equation equal to 0.
Right. Okay. X equals 8.
Mm-hmm.
So 8, 0. Okay, next one. Reflex over x-axis. Stretches by 3.
Mm-hmm.
Shifts to the right
Mm-hmm. 1
by
unit.
1.
Yeah.
And then shifts up by 1. Okay. Vertical asymptote is equal to 1. Okay. So when x is equal to 2, y is equal to 1.
Mm-hmm.
Okay. And when x is equal to 4, y is equal to 2.
Yeah, log base 3 of 3 is 1. 1 times -3 is -3. -3 plus 1 is -2.
And then to find the x-intercept, set it up with, or set the equation equal to 0.
Mm-hmm.
So -3 log base 3 x minus 1 equals -1. Log base 3 x minus 1 equals,
Oops, sorry, messed up.
we have to divide the 3,
Divide.
right?
That's right. Yeah, divide.
Okay, so that would be +1 over 3.
Mm-hmm.
So then 3 to the 1/3 equals x minus 1.
X. Oh yeah, x minus 1. I miscopied it.
Okay, so it is x minus 1?
It is, yeah.
Oh, okay. Okay, so 3 to the 1/3 Okay, so that's 3 to the 1/3 plus 1 equals x. Should I simplify it more, or can I leave it like that?
That's fine. Yeah.
Okay. So 3 to the 1/3 plus 1 and 0.
Mhm.
Okay. This stretches by 2.
Mhm.
And it shifts down by 1. And our vertical asymptote is 0.
Mhm.
Okay. So when x is equal to 1, y is equal to 1?
Well, what's the natural log of 1?
0.
Yeah.
Oh, and 0 times 2 is 0.
Right.
So it's -1.
0 minus 1 is -1.
Okay. And then when x is equal to e, y is equal to 1.
Right. Natural log of e is 1. 1 times 2 is 2. 2 minus 1 is 1. And there's one more that we can do.
We can do the 1 over e.
Yeah.
Equals -2 minus 1, which is -3.
Mhm.
So e's around 2.7, right?
Yeah. 2.7. You can think of 1 over e as around 1/3, maybe a little bit less, a little bit
Okay.
more actually. Yeah.
Okay. So then our domain is 0, infinity.
Mm-hmm.
Range is -infinity, infinity. And to find the x-intercept. E to the 1/2, 0. E to the 1/2 equals x.
Yeah.
Okay. Yeah. That's what I got.
Good.
Okay. 25. Okay, this one's going to shift right
Mm-hmm.
by 4.
Yeah.
Okay. And our vertical asymptote is 4.
Mm-hmm.
Okay. So for x to equal 1, no. For inside the parentheses to equal 1, x is going to equal 5,
Mm-hmm.
and y will equal 0.
Yeah.
And for inside the parentheses to be 1 over 3, x is going to have to be Let's see. Mhm. 2/3?
4 1/3, which is 13/3.
Oh, 13/3.
Around 4.3.
Okay.
So what happens when I insert 13/3 in here? This will cause the parentheses to be what?
Oh, 1/3.
Yeah. And log
And
base
then
1/3 is,
that makes it 1.
yeah.
Okay. Okay. So 5, 0, 4.31. Okay. And then domain 4 to infinity, range -infinity to infinity, x-intercept is 5, 0.
Right. Okay, good with this one?
Yes.
Okay.